This is 2024 paper 2 question 9, and we're given a diagram here, and we're told to write down the equation of the circle. So we're told the center and the radius, so you just have to fill into this equation here. So the equation of the circle S is just going to be x minus the x coordinate, which is 1, squared, plus y minus the y coordinate, which is 17, squared, equals the radius squared. The radius is 12, so the radius squared is 144. Then we're told that somebody's on the point A8 on the stream. So this is a point on the circle, so to find out the value of A, we can just sub in this point into the circle and figure out what A is. So basically, we can sub in the x-coordinate is A, so we'll have A minus 1 squared plus, and we'll have 8 minus 17 squared, because 8 is the y-coordinate, will be equal to 144. So we'll get A squared plus, or actually it'll be easier if we just leave it like that. And we bring this to the other side, and you'll see why now. So 8 minus 17 is 9, so then 9 squared gives you 81. So 144 minus 81 will give you 63. So I'll get A minus 1, the whole thing squared, equals 63. So again, that was just bringing this to the other side. And now I can just square root both sides, no need for the quadratic formula. That means that A minus 1 is equal to plus or minus 63 technically, but we're told that A is positive, so we can just take the positive one. So that means that A is going to be, or the square root of 63, sorry. So it's plus or minus the square root of 63, but we only care about the positive one, so we can get rid of the minus. So that means that A is equal to 1 plus the square root of 63. Answer in third form, so we're all good. So then we're told that Petro is at the point P 10.6. What's the shortest distance from the point P to the stream? So the way that this is going to work is the shortest distance is always the straight line distance. So we have to imagine drawing a straight line from C to P here. And the reason being is because if you imagine drawing it any other way, so I'll leave this red line here, but for example, let's say I drew the distance here, you can see that's going to be longer. If I drew it this way, that's also going to be longer. So the shortest distance is just from the point to the center of the circle. So we can find the distance between P and C, and then subtract off whatever the radius is, and then that'll give us this little section here. So that's what we're going to do. So the distance between these 2 points, we have a distance formula in coordinate geometry, which is this. So 10.6, that can be our x1 and our y1. And then our x2 and the y2 is 117 for the center of the circle. So you can say that x2 is equal to 1 and y2 is equal to 17. So the distance from P to C will be equal to the square root of the difference of the x values, which is going to be 10 minus 1 squared, plus the difference in the y values, which will be 6 minus 17 squared. And you can put that into your calculator, and you'll get the square root of 202. So 202. So that's the distance between P and C, the center of the circle. So we just need to take away from that the radius. So remember, the radius of the circle is 12. So the distance to circle, I'll just write distance, will be equal to the square root of 202 minus 12. And then they say to the nearest meter, so let's get a number on this. So when we do this, what we're going to get is about roughly, I'll say 2.2126. And the reason I'm giving that many decimal places is because remember that each unit is 100 meters. So we have to multiply this by 100 to get the distance in meters. So we multiply that by 100, we'll get 221.26. And then that becomes 221 meters when we go to the nearest meter. So then we're told some information here. So there's some path L. It's parallel to the y-axis. So basically, it's a vertical line like this. If I can get it to be completely straight, kind of like this. And then also it's tangent to the stream in the first quadrant. So it's going to be roughly there. And we're told to write down the equation of this path L. So we can actually quite easily figure out the x-coordinate because we know how many units horizontally this is. So since this is a vertical line, if we look horizontally here, so we know that this point here, the x-coordinate is 1. And then remember that the radius, so if we go from here to this vertical line, the radius is 12. So 1 plus 12 tells us that 1 point on this line is 13. So we know that the x-coordinate is equal to 13 on this line. And because it's a vertical line, basically what we want is that no matter what the value of y is, the x value should always be 13. So this is actually the equation that describes the path. So it seems a little simple, but the idea is that no matter what we choose for y, the x value will be 13. So for example, when y is 0, x is 13. When y is 1, x is 13. When y is up here, x is still 13. So it's a vertical line. Equations x equals 13. So then we're told the equation of w, and we're told to find the coordinates of the point on w that's closest to P 10.6. So the closest, I'll just get rid of this stuff here. The shortest distance is always perpendicular. So basically, this is the distance here. That's the shortest distance. If I just do this a bit more accurately. And then these are right angles. So what it tells us as a hint is we should find the equation of the line through P that is perpendicular to W. And the reason to say perpendicular to W is because remember, perpendicular means the shortest distance. So first of all, let's figure out what the slope of W is. So slope of W. Well, the slope of W, if we put this in the right form, we can say that x minus 9 is equal to 3y. That means that y is equal to 1 over 3 x minus 3. So let's just rearranging this equation, and we can see that the slope of W is equal to a third. So to get the perpendicular slope, we just take the negative reciprocal, and that'll give us minus 3. So basically, we know that the equation of this dotted red line, we know that it'll have a slope of minus 3, and the point is 10, 6, because we know that it goes through P and is perpendicular to W. So equation of a line, what's this? This is the perpendicular line, I suppose. So we'll have y equals mx plus c. So y is equal to minus 3x plus c, and then we know that 10, 6 is a point. So we can say that 6 is equal to minus 3 times 10 plus c. That's just subbing in the point. So then we have 6, and bring the 30 to the other side. We'll get that c is equal to 36, which should make sense. You can see that the y-intercept is going to be way up here. So that makes sense. So we have y equals minus 3x plus 36. And then we want to find the coordinates of the point on the road W that is closest. Okay, so we want to find the intersection of this dotted red line and the road W, and that's obviously the point that's closest to P. So this is the equation for the perpendicular line, the dotted red one. And then we want to find where it intersects this equation, x minus 3y equals 9. So x minus 3y equals 9. Yep. We need to solve these simultaneous equations. So we know y is equal to this stuff, so we can just sub it in here. So x minus 3 times minus 3x plus 36 is equal to 9. So then we'll get x, then we'll have these multiplied together, will give us plus 9x. And then minus 3 times 36, I think it's 108. It is indeed 108, so it'll be minus 108 equals 9. Then we can bring that to the other side, and we get that 10x is equal to 117. That means that x is equal to 11.7. And then we can figure out what y is, because we know y is equal to this. So y will be equal to minus 3 times 11.7 plus 36. And then that tells us that y is equal to 0.9. So that means that the point is 11.7, 0.9. Then in the final part, Fia is at this point here, 90. She travels 1,200 meters. What's the coordinate of the point where she stops? So 1,200 meters on our diagram, that's 12 units, because remember 100 meters is 1 unit. And there's a couple of different ways of doing this. I think the way that's probably most straightforward is we can think about the hypotenuse is 12, because remember that's the distance she's traveling at an angle. But then we have to figure out what these are. Obviously this is going to be the x, and this distance traveled, and this is going to be the y distance traveled, but then we'll have two unknowns that we won't be able to solve. So what we have to know is the slope of road W. Or you could figure out the angle as well using the slope. That's another possibility. But I think what will make most sense is if you get the equation of slope W, remember that the slope was a third, right? So the slope is equal to 1 over 3. So that means that means basically that the x value is increasing 3 times quicker than the y value, because basically the slope is like the rise over the run, or the change in y over the change in x. So that means if this changes by 1, this changes by 3. If this changes by 2, this changes by 6, because the ratio always has to be a third. So whatever the y value changes by, the x value will have to change by 3y. So that's kind of how we can set up our triangle, and then we can use Pythagoras' theorem. So y squared plus 3y, the whole thing squared, will be equal to 12 squared. So we'll have y squared, that'll be 10y squared is equal to 144, which means that y squared is equal to 14.4. Then you can get the square root of that. So y will be equal to 3.8. We're just told 1 decimal place. Yep. Now this isn't the exact y value, because remember that she starts at 90. So she starts at 90. She travels vertically 3.8. So we'll have to transform this. So vertically, the y is 3.8. So she goes up by 3.8. And And then how far does she travel horizontally? Remember, she travels 3 times more horizontally than she traveled vertically. So 3.8 multiplied by 3. So we can say that 3y is equal to 11.4. This is how far she travels horizontally, but she started at 9. So we'll have to do 9 plus 11.4, which will give us 20.4. And they're the coordinates that she stops at. The other thing you could have done is you could have said that a third is the slope, and then the slope is basically like the tan of the angle. So you'd be able to do the tan inverse of a third and figure out what the angle is. And then if you know the hypotenuse and you know an angle, you can use sine and cos to figure out what the two sides are. So that's another way of doing it. That might be easier.